Dey, bruh, why are you using kinematics? Huh? Why can't you use work energy power? Yeah lah. So why don't you use a energy one? No, why? I don't get it. No, the moment I see this question, I'm thinking you have to use energy. So you gotta think about like why, yeah, why. No, you see, okay, that's the thing. So you throw this equation down, right? You throw this equation down. I mean, let's see first, let's see first, bruh. You know where your mistake is? Your mistake is this thing here, right here, this one. Yeah, that one there. Okay. So hang on, let me just like your concept was right, but you used the wrong acceleration. You went to use 9.1, right? You shouldn't. I mean, you shouldn't have. Um. So like what how does it work then? So you got an object that's going up the slope, right? Okay. But like, what are the forces acting on it? Yeah, normal contact force. Yeah, you have the weight of the object, correct? Yeah, that's right. And what are you supposed to do? Resolve the weight, right? Ugh, the color doesn't work. Wait, let me see whether okay. Yes. Right, it's supposed to resolve the weight of the object, right? So like it's like mg mg what sine 30 and mg cosine 30, right? Do you see that? But so what's the resultant force acting on this object? Bruh, u is the initial speed. You cannot take speed minus force. So the resultant force acting on this object is truly just this. M just sine 30 only. Yeah. The mg sine 30, the mg sine 30, right? Mg sine 30 is equals to the ma. The a equals to g sine 30 down the slope. So so that's what you're missing here. The, that part there, right? You're missing this part here, right? The negative 9.1 sine 30, which is why you see the answer key says this, right? But if I just tell you that the acceleration is 9.1 sine 30, you might not understand why. So that's why I need to show you the forces first, right? Which is why I'm just thinking like, why do you use forces to answer this, or kinematics to answer this? It's more tedious. You should just use energy, like the half mv squared, which is the half mu squared, which is the ke, right? Being converted into GPE. Mm-mm. Always remember, energy method is always easier. Okay, I'll not say always lah, right? Yeah. And whenever you deal with slope stuff, going up the slope, like calculating speed, calculating how far it travels, no time factor. They didn't give you any time factor. Do you see any time factor around? No time factor, right? No time factor means you don't need to use kinematics. I mean, distance and all that. The key, I think one of the key triggers is you give me distance, right? You ask me to calculate distance, I use energy. Okay, can okay, good. So this one, okay, settled already. I do round robin. Let me go to Harry now. Harry. Okay, Harry, this one. What, this one? Hey, do you ask me for videos? You did ah? I haven't replied you yet, is it? Then no, I did what? Then you still don't understand? Wait ah, we are traveling with. This is a GIF. This is a GIF. This is standing wave, standing wave. Oh no, so no. No, I did not send you. I did not send you. No, you asked me for GIF showing transverse waves and longitudinal waves. Yeah, no. Like if I see that this was your question, I would ask you to send me a request for my Sec 3, Sec 4 wave videos. Yeah, this is covered in Sec 3, Sec 4. Yeah. Hang on, let's see first. Oh no, this is standing wave. Yeah, this is standing wave, right? Standing wave, okay. So this is a standing wave. Standing wave, Okay, no, then my Sec 3, Sec 4, no such videos. Okay. Alright. So even after you see the GIF, you still don't understand. That means even after you see, were the GIFs moving? They were moving. Okay, so you could see them moving, but you still couldn't understand. Okay, let me just try my luck here. Let me try to see myself. These are all from your prelims, right? Okay. Yeah. Open sesame. Looks a bit stuck. Let me try again. Open sesame. Ah, there you go. Okay. This is standing wave, right? You see the notes here, right? Okay. What do you understand about? Okay, okay. Actually, I don't even know what the question is. What do they want you to ask? Distinguish between progressive waves and stationary waves in terms of amplitudes and phases of oscillations. What? They are, huh? Okay, wait, wait. I think I'm not understanding the way you're asking your question. Where? Oh, it's on another page. I was like wondering what are you talking about? I have no idea what you're talking about. Um, yeah, I don't have your paper. Please understand that. Like I'm please don't assume that I know what's going on. You have to tell me everything. You have to be explicit about it. Um, okay. Because sometimes the way you ask, the way you understand the question, is sometimes the way you ask the question back to me, right? As I a bit suspect, might not be the same thing. Hang on, let's see first. The wavelength, deduce with explanation the wavelength, and you were able to find the wavelength, right? Distance between two successive compressions. Is that right? Do you doubt that answer? No, right? Like this compression here to that compression there, right? Okay, okay. Then they ask you amplitude, is it? Then basically you're supposed to state the maximum displacement of particle from its equilibrium position, is it? Okay, right. Uh, okay. But you see, right? The problem is that this is a standing wave, right? And there are some particles that don't actually move at all. They never moved at all, right? So this is not like the same like in secondary school. In secondary school when you were supposed to find the amplitude, you look for the particle that has the maximum displacement, right? Like, do you notice that this particle here, the one I just highlighted yellow, do you realize that it didn't move at all, right? Yeah. So which particle is showing the amplitude then? No, then you see this dude here? Like this one here also, the compression also never moved at all, right? Okay. So and then the I think the worst thing is that for figure 3.1 kind of like doesn't really show you where they kind of like they're not in equilibrium. They're like like yeah. Okay, wait now. Figure 3.1 and figure 3.2, right? So am I right to say that figure 3.1 is a progressive sound wave, while figure 3.2 is a stationary wave? Okay, hang on. I find it very strange. They ask you, haha, now I know. I was wondering what they are trying to do here. I was like wondering, yeah, I was so confused. They want you to find the amplitude of figure 3.1, not figure 3.2, right? Yeah, that means they want you to find the amplitude of the original progressive wave. You know why? You know why I kind of like suspect that they weren't asking you for the amplitude of figure 3.2? Because for figure 3.2, right, every different particle has a different amplitude. You see this particle has no amplitude, right? Whereas whereas for like this particle here, it has a certain amplitude. That red particle there is the antinode. It has the biggest amplitude. So different particles have different amplitudes. So from my understanding of that, I kind of like figured out, oh, okay, so actually they only want you to find the amplitude of figure 3.1. So sorry, it is true. It is a maximum displacement from equilibrium. Okay? So we have to go back to the question, and we have to try to understand for the progressive wave 3.1, where were their original amplitudes? Because they don't look like they're at their original amplitudes. Oh, whoops. What did I do? Yeah, sorry. Right, figure 3.1, right? Yeah. So where are their original amplitudes? So where are their original positions? Like they are not in their original positions, right? Yeah, they are like kind of like in the middle of like forming. This is a rarefaction and this is a compression. So so if this is a compression and this one's a rarefaction, right? Do you understand that compressions and rarefactions are back at their equilibrium positions? Okay. For progressive sound wave, you understand that, right? Do you can I divide this space by 5 particles? Like let's try to find out where they were originally at. Yeah, like where were they all originally at? Is it 3 boxes away from each other or 2 boxes away? One, two, how many? One, two, three, four, five. 5 particles. How much space do I have? 0.3. Or actually, I should count as 6 lah. I should count as 6. So starting from point position 0 here, right? Then particle one, 2, 3, 4, 5, and 6, right? I need to distribute these 5 back into this space here. You know what I'm saying? I need to distribute these 5 into this space here like this. So that, I can, yeah. How much? How far should it be spaced? 3 by 3 by 3 by 3? No, that's only 4. right? So come on, 2.5, 2, 3, 4, 2.5, right? Yeah. Then you so this guy is 1, 2, 3, 4, 5, right? And then you choose which one got displaced by the most. Look like number 3 got displaced by the most. Okay. Is that what the answer key says? I don't know. You know what? Do you know what method I'm using? I'm just going by the definition. Like, what's the definition? Maximum displacement from equilibrium. So I'm trying to find the equilibrium position, and I'm trying to find the right now the displacement, and trying to find out which one has the biggest distance, and then that's your amplitude, lor. Yeah. I mean, which is two squares. Yeah, two squares. You can, I guess you can say that. No, but even if no, you see, right? Even if you identify like, oh, particle 3, the middle particle has the greatest displacement, right? Because between compression and refraction, that's the biggest amplitude, right? Um, that but how much? Isn't that what the question is asking for? Like, how much? What's the distance between the particles? Oh, shit. No, no, dude. So the problem with 3.1 and 3.2 is that they're completely unrelated. Yeah, yeah, yeah. 3.1 is a progressive wave and 3.2 is a standing wave. Like, they are really not related at all. Yeah. Hey, who Xavier ah? Oi. Yeah, he keeps on going on and off. What the heck? Hello, Xavier. Ah, no lah. It's not what? It's two squares only what? Yeah, it's only two squares. Like how much distance is two squares? 0.04. Bruh. Wait, don't tell me it's a careless mistake. What? Where? Huh? What? Uh-huh. What? He very passive aggressive. Hmm. Okay, but anyway, so that's the amplitude, okay? Okay. And displacement nodes and displacement antinodes. Wow, hey, his network is damn bad, eh. Wow, the fella just dropping on and off the whole time. This one, no problem. This one, the pressure one also. You understand? Technically not allowed. Actually, I think there's a syllabus point in the guide that says that students are not required to know the pressure. Yeah, yeah, lor, that's why. Yeah. Okay. Anyway, Hey, Xavier, you okay or not? Alamak, Xavier. Hey, what's this? Xavier, you okay or not? Hello? Yeah, hi. What? Huh? What? I'm not frozen. What are you talking about? Yeah, I called your name. Why are you asking me whether you can join the call? You can Why? How am I supposed to know that he's with you at 9:30 p.m. at night? What the hell? Okay, wait, hold on. Your internet connection okay or not? Just now you keep on logging on and off many times. Okay, okay, can. Sorry. So wait, let me just do one more for Harry, okay? Wait, what's this about? So the rest of it okay, Hey, bruh, brother, you never hear me say before, man. I said it many times, right? Don't leave your answer in certs or in fraction or in any none. It's all decimal. Why you go and leave it? You go and lose this 1 mark for what, yeah? Hey, oi, why I don't get it. Okay, anyway, you got the answer or not for this one? Mm, This is not math. This is physics. Give me decimals. Wait, what's your question here? Where? Yeah, I know, but then why is this a marking point? That's damn dumb lah. No lah. I mean, there is a reaction force here. There is a reaction force here somewhere, right? But we don't know where's the reaction force there, right? Then if you would want me to rotate it around the corner, I understand it loses contact here. Then why do I have to put this in? No need one lah. I know the normal. I understand. I understand that. I understand that. But even at Sec 3 also, the question doesn't even require you to state that the normal contact force is zero. I mean, it's quite duh, like, I know, right? Why is it a marking point? So you're not asking me why is the n zero? You know why the n is zero, is it? You're asking me why your school minus 1 mark from you for not writing the n equals zero, right? I don't think so. I I don't know why they're so yeah, passive aggressive. Why they so being so anal now? Like strange. It's like they know that their students can work out everything, but they just want to find marks to minus marks from. That don't make sense, no sense. Okay, but anyway, yes, the normal contact force here will be zero. I highly doubt that you have to ever mention that in actual A levels. All right, so you don't have to worry about it. I guess the idea is that you can just find the answer anyway, right? Yeah. But what's the trick to this question here? Like what do you think was the trick to this question here? No, actually the trick is just trying to find this distance, isn't it? Like wasn't the trick trying to find this which distance was it? Was it this distance? Right? That perpendicular distance, right? Oh, that's not oh not the one. Oh, uh is this distance here, this one here, this one, yeah, that one. But I don't know whether you remember this. If you have done this in secondary school, you remember that, yeah, it's a right angle triangle here, right? It's a right angle triangle here. This is the radius, right? Like that's the radius there, right? Oh wow, why do you call it R? Oh, the dotted line. Okay, okay, that's R. Okay, sorry. But yeah lah. Then and this one is half R, is it? Yeah, half R, and therefore you can find this distance here. Like you need this distance anyway. So I guess you already knew that. So you already did all the calculations here. I can see. You can lose 1 mark for not writing decimals. They okay lah. You lose 1 mark for not writing the end. I think it's unfair. That's not. It's not a thing in the A levels. I'm very sure of that. Yeah, it's so strange. They're so anal. Um, anything else? Apa nama? I go to Xavier's question now. Wait ah. Xavier, which one ah? Xavier? Xavier, this one also ah. The second part ah. Then you never pay attention to what I was saying just now. It shouldn't be a marking point. Yeah, it doesn't matter at all. The only two things that you need to consider is the weight, right? Then multiplied by this distance. So mg multiplied by this distance, mg times d, okay? As well as the force here, right? The force here, this is the force, and multiplied by this d2 here. So when you do the calculations, it will be like mg times d is equals to force times d2. Correct, right? Yeah, I mean, like what I was mentioning just now, the tough part is trying to find d, because d is the Pythagoras, right? The Pythagoras difference of the hypotenuse squared and this height of the triangle squared, then square root. Correct or not? Yeah, that's pretty much it. So that's for the first part. Yes, the people which is r over two. D no D2 is r over two, bruh. This you're talking about this distance here? Yeah, that's r over two because the radius of the circle is here, right? Then the box is r over two. So this height here is r over two, and therefore this distance here is r over two. Correct? Right? You're supposed to use not trigo. You're supposed to use Pythagoras to find this distance here instead. This one here, right? mg times d is the clockwise moments, sorry, anti-clockwise moments, and f times d2 is the clockwise moments around this pivot. Yes. Then you want to ask about the second one? Yeah. So second one is without, like, I mean, it's like if the box is at the same height uh to the middle of the the sphere, right? Like something like this. So let's say it's changed to this, right? R here like that. Okay. Then you have to apply a force this way, right? You have to apply the force at an angle like that. Then it will, you know, or you can apply at the edge. I think I don't know whether they allow you to apply the force at the edge. Are you allowed? Yeah lah. If you increase the magnitude of the force, it's not good enough because you're acting at the pivot. When you act the force at the pivot, there's no moments. No moments means cannot turn over. Yeah. So I would. Do they allow you to act on the side of the disc like that? I mean, I would write that down now. I mean, if the answer is like this, it says state and explain. Oh no, acting at center O, so I can't change that. So it has to be at an angle, lor. Yeah. Hello. What's okay. Cannot lah. The language, whoever said this thing, the language is damn bad. Leh. You say state and explain how the force acting at center O would need to be changed, right? Then it's like I would still want to try to keep it at center O. I wouldn't dare to put it at the side of the disc, right? Because of the way you ask this question, right? Acting at center O, right or not? Yeah. Stupid lah. Why whoever said this thing is them got communication problems, you know. Right. Okay, but anyway, this will work. Okay, so you incline it upwards, you apply a force this way, right? At center O, it will cause the this. I mean, one way or another, it will cause it to roll over. Okay. Okay, can. Well, next one is who? Next one is wait, actually send me anything. You send this one. This one. Hang on. Sorry, I just need to transport it over to my PowerPoint. Hang on. Okay. What's this? Part two, is it? Right now. Who calls it deuteron? It's deuterium. What the freak? What kind of What? How old is this word? This is damn old, eh. Who the hell is setting all these questions? Some old foggy guy, is it or what? Oh no. Okay. Wait. Deuterium is readily found on Earth, but not helium. 2 helium. What the hell? 2 helium. Sorry. There's the outcome. Two possible outcomes. Helium. 2 helium. Dude, 2 helium is a very impossible particle to exist. Two, no, two helium is simply just 2 protons. There's no neutrons. Yeah, no way. You need neutrons to stabilize the thing. 2 helium at least is possible, but 2 helium, wow, that's impossible. Like you have 2 protons next to each other, dying to repel each other, and then yet they're bonded in the nucleus. No, like it's. I mean, yeah, it's probably a momentary thing. It's probably like it just is not stable. I would just simply say that it's absolutely not stable, and it will. Yeah. Which one will release more energy? No, which one will release more energy? If I consider the fact that this guy will break down further, right? Do I consider energy release after it breaks down? Like okay, if it's unstable, it will continue to break down, to decay actually, right? And then wouldn't it release energy right after that? Like the total amount of energy would be like quite similar to this anyway. But okay lah, that I think they're just asking you to compare this and this, right? Okay, no, this question is not a good question. They should be asking which one is more likely to happen. Yeah, they should be asking which one is more likely to happen, you know? And reaction two is more likely to happen, right? Because reaction one is likely that if you form this 2 helium, it's probably very unstable. So it's not likely that you got two reactants to form a highly unstable nuclei. I would say that it's just not energetically favorable. Like like if you want me to force like something to do with energy, right? Which one releases more energy? I wouldn't even consider like which one would release more energy. I would consider which one is more feasible. This is more feasible. You know what I mean? Feasible, right? This one is not feasible. Okay, right? That means it wouldn't even happen in the first place. How would I compare which one releases more energy? You get what I'm saying? Yeah, yeah. Because this one becomes very unstable, right? Unstable, right? Okay. When you want to make unstable products, let's say you have some reactants and you go ahead and make unstable products, what will happen? Now you have to put energy in, right? You have to put energy into the system. Like you won't even release energy. Like you have to add energy in. So it's not even a, a, a proper question to ask me which one releases more energy. It's like, is it even energetically feasible in the first place? First reaction is no. Yeah. Wait, let me see first. No, no, no. I'm looking at their mark scheme. Okay, so they're using stability as an indication for what releases more energy. So it is very similar to what we are saying, right? But I wouldn't even entertain the idea that reaction one is even possible. You get what I'm saying? Yeah, because I honestly don't think that it can actually happen. Like reaction one. Like it feels like the and somewhat, deuterium is readily found on Earth, but not helium isotope 22 helium. Honestly, is it even easily found anywhere else? Why would you even write it like that? You get what I'm saying? Is it even found anywhere else on Earth? So you're saying that somewhere else may have more? The moon? Mars? No, it shouldn't exist anywhere. Yeah, I wouldn't think it would exist anywhere. It is not energetically favorable to have such a type of isotope. It doesn't make any sense. If you go from no no as in it's just it's a very straightforward thing, okay, right? So it's like that, unstable, right? Unstable nuclei, right? Unstable nuclei. Like what would it do? Mm. So if it's unstable nuclei, there's one pathway it can decay, right? And if it decays, it becomes stable, right? The act of decaying is a release of energy, right? Or you can make an unstable nuclei undergo through fission or fusion, right? And then if your end product is stable, the very fact that it becomes stable means that energy must be released. Akshay, are you asking about this question because you don't take chem? Yeah. So it's the energy levels thing. Like if your reactants has high energy levels and it's an exothermic reaction, it will have to release energy to become a stable product, a lower energy level. But that's like, we can't use words like exothermic here, right? But the concept is pretty much the same. If you're unstable, that means you got a lot of energy going on, and you do something, yeah, correct, you release it and you become stable. So the idea here is, if the eventuality becomes you get a stable product, it means that. And what are you talking about? Sorry, what? Yeah, 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 exactly, yeah. So if you're stable, you can't do anything like after that. Like if you are stable already, that's it, you know. Yeah, that's pretty much it. Yeah. Okay, Ken, that was that one. uh Wait, Harry, this one. Okay, what are we trying to get them to do, right? So what's the problem with trying to get two hydrogen nuclei to fuse? Why? Why can't we just put them next to each other and they fuse? No, it's not about stability. It's because they're positively charged. You got one positive charge, you got one positive charge. Do you think they want to go near each other? No. So essentially, what you want to do is you want to shoot them towards each other with enough KE so they can approach each other until they touch and then they fuse. Yeah. So how much KE do you need? And what will happen to the KE as two positive charges approach each other? Yeah, that's it, right? So when they do touch though, what's the distance between their centers? Yeah, the radius times 2, right? The distance there is basically this distance times 2. Okay? And basically you just need to calculate the I mean the KE required is basically the EP they get when they're next to each other. Yeah? Yeah? Okay. That's it lah for this one. Wait Xavier's turn? Oh, Xavier done? Hang on What? What do you do? What happened to you? Wow, then you just skip the paper. Okay. What? Yeah, end correction is not a syllabus. Yeah, that's right. Yeah lah, not fair lah. Okay. Okay, this one This one North and south Right? You want to ask about this one, is it? Not this one, right? The explanation, this one you can get it from your school, the marking scheme, right? Okay, so you're asking about this diagram here, is it? Okay. Why that? Is that blanco? Oh, okay. Okay, so I draw my own. Okay. Wait So this is the disk, right? And this is the magnetic field was where? Magnetic field was here, is it? Was it there? Is that right? Okay, can. So and the disk is spinning this way, right? Okay. Wait, how's the magnetic field coming? How's the magnetic field look like? From the bottom to the top. So let's say this is top view, right? Top view, So am I right? Is it coming out of the page? Okay, coming out of the page, Okay. Can. So I want you to imagine, correct or not? Okay, wait, I zoom in a bit. Okay, okay. Do you notice this region here? So I want you to notice this region here. Okay, hello. Okay. Do you notice that this region is going towards? Okay, so this region here. So I imagine that this region of the disk is now going towards into that field area there, right? Okay. This region of the disk. I just drew some random shape lah. Honestly speaking, it's just let me just move this out of the way first. Hang on. Maybe it's not a good picture. Like let's consider a circular region lah. Okay, can. Okay. So this area of the disc is going in, okay, good. This area of the disc experiences what? Oh, sorry. Mm. So yeah, change in flux indicates induced EMF, blah 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 blah, right? Okay, so if it's going in towards this region, there's an increase in flux pointing out of the page. Use your right hand grip rule, right? So what happens is that it will try to create flux. Yeah, you're right. It will try to create flux that's going into the page, right? So you actually use your right hand grip rule. The eddy current inside this region will be using your right hand grip rule will be a clockwise current. Then as it's going out, right, as it's going out like this, on its way out, right, it will try to create flux that's pointing out of the page, right? So then you use your right hand grip rule, then it will be anti-clockwise, right or not? Yeah, I mean, yeah lah, that's the answer. So you have to okay. I mean, region P and region Q. That means the top and the bottom, right? Okay, so that means around the region here. I mean, yeah lah, around this region here, right? The top region is P and this Q, right? So around the top, the eddy current is this way, and then around the bottom, the eddy current is this way. Like that lah, like that and like that. Okay, can like this. Yeah, but then oh, okay. You drew as a whole thing. Yeah, it's not. It's the in and out. Yeah. So the understanding is the you know the yeah the going in and the going out regions. Yeah. Okay. Wait this one this one understand already, right? Yeah, this one understand. That's it. Okay, can. That's it, Okay. Um, any others? Not at the moment. Okay, no worries. If you still find any, just let me know. Okay. But maybe I request that we stop this session now today. Because my sec threes are a bunch of idiots, and they forgot to inform me that they no, because they got paper one tomorrow, and they forgot to tell me that they have a paper one tomorrow. So I gladly went to cancel today's lesson, right? And then now they're sending me questions because now they realize that, oh shit, I wish I can tell their parents that also. So anyway, so the parents are asking me, hey, how come there's no lesson tomorrow? You got exam. Freak lah. Then they didn't tell me, right? They didn't inform me. This sometimes okay. The problem with the younger ones is that they have very poor communication skills, right? So actually that's my gripe. Like you don't communicate with me early on. You last minute question dump me. Then you say like, oh, I don't know how to do all this. I don't have time to answer you. Then everyone loses, right? So you always think about like, for asking for help and getting help and all that. You have to learn how to ask good questions too. Okay, never mind. I have to go and settle them. Let me know if you have any more questions. I'll see you guys on Sunday. All right, Ken? Yeah, 2020 and Diamond High have to do Diamond High already because we only have 13th, 17th and 20th. Like I will ask you to attend the 17th online, right? 13th, 17th, and 20th for the practical. Um, then one more thing, how pay? How pay? Huh? What? Where is he? Is he not there? He's with you, right? No. I just want you to tell me what are the questions that you need me to cover from your prelim paper. My computer clock by 2 minutes, what? No, that's fine because long story. Anyway, okay. Can how about drop me a message on the questions that you have, then I try to find a time to arrange with you for your consult as well. Okay, okay, bye 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 bye. Okay, go 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 go. Thanks, thanks, thanks. Bye bye.